The initial velocity of a particle is u and the acceleration f is given by at square. Its velocity at time t is given by. See, there are many questions which come in this format, and it's almost all of them have the same logic, and that's the primary reason why I have not taken similar questions like this. So let me just try to tell you how to do this question. It's a very simple question, and the only point I feel here is different, or let's say it's tricky, is that they have exchanged the commonly used notation a for acceleration with f. This is all what they have done. So let us say acceleration, right? Acceleration is nothing but rate of change of velocity, right? So instead of using a is equal to dv by dt, what we should be doing here is use dv by dt is equal to f as given in the question, right? So what is f? F is given as dv by dt. Not just that, what we also have is the velocity, the expression for acceleration given as at square. That's it, we're done with the question. Now dv by dt is equal to at square, in which case what is dv is equal to, you cross multiply dt over here, so that becomes at square times dt. This is in the variable separable form, in which case dv is equal to at square dt can be integrated on both the sides. Now see, when we integrate, we need to have the limits. See, what is dv, or change in velocity, which means the variable there is the velocity. What is the variable on the right hand side? It is dt, which is basically time. Now how will the velocity vary? The velocity will vary from the initial velocity to the final velocity. What is the initial velocity? The initial velocity is u. What is the final velocity? It is v, which means the velocity will vary from lower limit u to final limit v. How will the time vary? The time will vary from the starting time of observation, which is basically t is equal to 0, to any time t is equal to t at any instant of time t, which means the lower limit of time will be 0 and upper limit for time would be t. Now the integration is straightforward task. What is integral of dv? Integral of dv is v, and the v will vary from u to v. What is the integral of at square? A is a constant. Integral of t square is t cube upon 3, varying from 0 to t, which means upper limit minus lower limit v minus u is equal to a into t cube by 3 minus 0 cube by 3, which further will be equal to v minus u is equal to a into t cube by 3. And therefore we can say that v is equal to u plus a t cube by 3. So this is the required relationship, in which case the correct option is option 2. And you should always keep this in mind, that again here a is not equal to the acceleration. A is given as a different constant. It is not the usual notation that is used to describe acceleration. So the point why I highlighted this after concluding the solution is that if in case you get a question for further manipulation of the algebraic expression, you should keep this in mind, that a is not equal to the acceleration. It's a constant.